Hi, hello everyone. Welcome back to my YouTube channel. My name is Nitin and I'm studying in Sterling Register College of Engineering in the Department of Data Science. And today's subject is digital design and computer organization. In this session, we will study about the computer generations, processor types, and digital designs. Several key shifts in processor architecture, speed, and operations are covered. In this, we have first generation, second generation, and third generation, fourth, fifth, and sixth generation computing. Let us dive into the deep world of computer. In the first generation, we used to see the vacuum tube based processor, and the architecture of this processor is the operation is limited to basic arithmetic operations and program control. Operations were sequential, linear, and input output are very slow. Computer organization. Simple binary operations performed by machine language. Processor operating speed, it is very slow processor as we know, so it's operating at kilohertz level, means very low level, and the bit size is about 8 to 16 bit. Digital design, in this the logic designs was quite basic, typically using binary operations, and the example of this generation processors are UNIAC and UNIVAC. Second generation, and the second generation, the transistors based processor, and it is came into force in 1950s to 1960, and the main architecture of this generation processor is transistors allowed more operations per clock cycle, and these systems operated rudimentarily operating system with batch processing, and the organization of the computer is in this introduction of more modular designs have been made. Assembly languages made it easier to program. Magnetic core memory was introduced, speeding of memory access. Processor operating speed, it operates in microsecond levels and operating at a few megahertz. And the size of bits is 16 to 32 bits. And the digital design consists of transistors replaced vacuum tubes, reducing size, heat, and power consumption. The logic was still simple and relied on basic gates like AND, OR, and NOT gates. Third generation. In the third generation, we will see a small scale integration, SSI processors, and medium scale integration, ICS, and MSI processors. And the operations are better multitasking support, include hardware interrupts, and more complex instruction sets for logical, arithmetical, and memory operations. Cache memory was introduced to increase processor speed. Computer organization. In this, multiprogramming and time sharing becomes feasible. Processor now could support high level programming languages like front-end and COBOL. Instruction sets began to standardize. Third generation. In the third generation processor, operating speed, it operates on megahertz to tens of megahertz with a nano speed. And the size of these bits or 16 bits processors were common with 32-bit architecture starting to emerge. Digital design of this processor integrated circuits allowed multiple transistors to be placed on single chip, vastly reducing the size of the computers and increasing their reliability. Example of this generation computers are IBM System 360 and PDP-11. Fourth generation. And the processor is microprocessor VLSI, very large scale integration. And the architecture operation is multi-threading, pipeline, and cache hierarchies become common. CISC processors had complex, varied instructions, while RISC processor focused on fast, simple instruction. It consists two different processors. One is CISC and RISC, where CISC is a complex instructions that could execute multiple operations in one step, and RISC is a simplified instruction sets optimized for speed execution instruction in one clock cycle. Computer organization, the key architecture were CISC and RISC, and the processor speed ranging from the few megahertz to hundreds of megahertz by the late 1980s, and the size of the what is 16 bits processors gave way to 32-bit processor. The design VLSI technology allowed entire processors to integrate in onto a single chip. This led to the development of personal computers and mass market computing devices. And the examples of this generation computers are Intel 8086 16-byte, Intel 80386 32 bytes, Motorola 68000. Fifth generation. It is a multi-core processor, 64 architecture, 64-bit processors were came into exist in the fifth generation. And the operations consist parallel computing through multiple core and multi-threading, use of out of order execution, branch prediction, and speculate execution to improve throughput. Send and vector processing units became common in both general purpose CPUs and specialized GPUs. Computer organization, the architectures advanced to include parallel processing via multi-core and multi-threading designs. SMT simulate simultaneous multi-threading and SIMD single instruction multiple data architectures helped boost computational power, virtual memory, and cache management became highly sophisticated. Operating speed of this generation computers is gigahertz. It works on the operation of gigahertz level with modern CPUs reaching speed of up to 5 gigahertz, and the size of these processors are 64-bit processor and became a standard, allowing large amount of memory up to several terabytes and byte better performance with large data sets. And it consists of very deep submicron design, which is transistor features smaller than 1 micron, and multi-core architecture dominate. GPUs also emerge as important co-processors for highly parallel tasks. Example: Intel Core i7, AMD Ryzen, Apple M1, etc. And at present, we are a sixth generation, which consists of quantum processors and neuromorphic processors. Operations of these processors are quantum processors will be able to solve complex problems like factoring large numbers exponentially faster than classical computers. Neuromorphic systems can process sensory data and adapt in real time, ideal for AI driven applications. And the organization of these processors or quantum processor can perform certain operations much faster than classical computers. By leveraging quantum phenomena like superposition entanglement, neuromorphic chips emulate how biological neural networks operate. And the operating speed of these processors are teraflops for classical processor, with quantum processor measured in qubits. And the bits size include classical systems still rely on 64 bytes, but in quantum processors we use qubits which handle more complex data representations. Digital design of these processors or designs are moving towards quantum computing using qubits that can be in superposition 0 and 1 at the same time. For vastly faster computation in specific applications, neuromorphic computing uses brains inspired architectures to solve AI and machine learning problems more efficiently. Example of this type of processors are IBM quantum processor and Intel Lohi neuromorphic chip. Conclusion: the transition across generation in computer design reflects vast improvements in digital logic, speed, operational complexity, and bit processing capabilities. All of this which are essential to the continued progress of computing technology. Thank you. That is for today's session. Please like the video, share and subscribe.